Hey guys, my name is Iman and today we're going to learn about how to do non-preemptive shortest job first. So basically in non-preemptive shortest job first, we have to focus on the amount of burst time. So the shortest burst time will go the first in the Gantt chart. So basically in this question, we see that our processes have different burst time and different arrival time, but the priority does not play a role in non-preemptive shortest job first. So basically we have to start with the Gantt chart. So basically it's basically a table. Okay, so basically for the first part we have to find arrival time 0. So the process 4 is the arrival time is 0, so that will be the first process in the Gantt chart, so 0, and after that the burst time, which is 3. After that, we look at the next process which arrived within this time span. So between 0 to 3, the process that arrived during this time is process 3, which is process 3 equals to the burst time of 5 milliseconds. So we can just add there. So process 3 plus 5 is equals to 8. So during this period of time, there are multiple processes that join this Gantt chart. So for example, if we look at the table, so for example process 1, which arrived at 4 milliseconds, which had the burst time of 9 milliseconds, and also the process 5, which has the burst time of 4 milliseconds. So based on this, we have to take the shortest job, so the shortest amount of burst time. So the shortest shortest amount of burst time between these two are process 5. So process 5, we write it down. So 8 plus 4 is basically 12. So we can just write it off and write this off earlier. So during this period of time, it is now joined by process 2, which is arrived at 9 milliseconds, which has the value of 6 milliseconds. So we already have all the values here. So the shortest job is P2, which is 6 milliseconds, which is 18, and finally P1, which brings 9 milliseconds, which brings the value of 27 milliseconds. So to find the waiting time, basically we have to use the formula, which is for each processes actual arrival time minus the arrival time in the table. So for process 1, the actual arrival time is 18 minus, which is the arrival time here, which is 4, which is equals to 14 milliseconds. For process 2, the actual arrival time is 12 minus 9 equals to 3 milliseconds. Process 3 is the actual arrival time is 3 minus 2 equals to 1 millisecond. Process 4, the actual arrival time is 0 minus the arrival time 0 equals to 0 milliseconds. And process 5 is 8 minus 7 equals to 1 millisecond. So after we gather all this information, we can find the average waiting time. So basically the average waiting time, or like I wrote down AWT, is equals to the waiting time, or the total waiting time over the number of processes. So in our chart here, in our calculation here, so the total waiting time would be 14 plus 3 plus 1 plus 0 plus 1 divided by 1, 2, 3, 4, 5 processes. So that will be divided by 5. So that would be 19 over 5. So which is equals to 3.8 milliseconds.
Hey guys, Jeff here. So today I'm going to talk about non-preemptive priority. So basically, in non-preemptive priority, priority is the important part of this. So to start the Gantt chart, first I'll draw the Gantt chart. You're gonna have to see the arrival time, so 0, which is P3, and its burst time is 4. So since it's non-preemptive, you can just write 4 over there. And because it's 4, two processes is in a ready state, which is P1 and P5, so you can write that down. And their burst time, and to make it easier, you can just put their priority at the side so you can do it. Okay, and P5, which is 13, and their priority is 4. So based on these two, the lowest priority would be the highest priority would be the lowest number, and in this case would be P5. So you just write P5 over here, and so 4 plus 13 would be 17. So you can just write 17 over here, and to make it easy, you could just cross that out. And now the processor is in 17, so all is in a ready state, so you could just write everything down. So P4 with arrival time 6, burst time 6, and your priority 5, and then P2, which has a burst time of 12, and their priority is 3, and their P12. Okay, so now that all the processors is ready, you can just start with the highest priority, which is P2. So just write down P2. So 17 plus 12 would be 29. So just write 29 and just cut that off. And then next you can just write P4, and then P4 plus 6, 29 plus 6. 29 plus 6 would be 35. So you cut that off. Then next you write P1, so 35 plus 8, and that would be 43, and you got your Gantt chart, and that is non-preemptive priority. Okay, so now we're gonna calculate the waiting time. So the formula for waiting time is actual arrival time minus arrival time. Right? So for P1, start with P1. So P1 is equal to 35 minus, so right here at the arrival time for P1 you got 4, so it's equal to 31. So next is P2, you have a 17 minus 3, which is 14. Then P3. Alright, and the last step is to calculate the average waiting time, which is average average waiting time would be divided by the number of processors. So that would be 31 plus 14 plus 0 plus 23 and then plus 2, and that would be 1 second. Oh yeah, and don't forget the divided by 5 because it is the number of processors. And give me a second. And the answer would be 14, and that's how it's done.